So, this second video is going to be about our own glorious and life giving star, which we call the sun. So, our sun drives life itself on this beautiful planet, all the plants and all the microbes, and we humans, we all need sun to convert energy into consumable energy that can drive our life forces. So, isn't our sun great? It is. Can you imagine if the sun just vanishes from the sky? What would happen? All the complex life, including us, plants, animals, herbivores, all would be gone in a few months or a few years. It's scary. So, well, the question might come in our minds, what are the basic features of our sun, of this very important object in the sky? So, what comes into our mind when we have to describe an object, a person also? It's mass, isn't it? So, what do you think? What could be the mass of our own sun? What would be the figure? What would be the 10 to the raised power something? Let me tell you, it's 2 into 10 to the power 30 kilograms. It's huge. And just imagine the cosmic scales, how big they are. What's its radius? It's also in the figure of 7 into 10 to the power 8 meters, which is around roughly around zero point 0.7 million kilometers. Huge. And there is a data which says that 109 Earths can fit inside the uh, diametric dimension of the sun. Just imagine the scale. This is our solar system, and it is very tiny compared to other solar systems and the galaxy itself. So, we are very lucky that we have this certain intelligence that we can gaze into the night sky and use our instruments to describe certain parts of the universe with great precision. And thanks to our scientists and all those people who worked hard day and night to bring knowledge to us, to all the people. And we should not take their hard work for granted. And we should also try to emulate them, which I would prefer if everyone in on this planet tried or tries at least. What can be the age of our sun? What do you think? A billion years old? 2 billion? 3 billion? No. It's 4.6 billion years old and it's almost halfway through its life. It has another 5 billion years up ahead of steady shining. And there is a caveat and a sad end. After these 5 billion years of further steady shining, it will expand into a red giant, huge. It would the structure that you see right now, it would expand and it would consume all the inner planets, including our own Earth. But remember, Earth will not become, we will not go there, will not wait till 5 billion years. In another 1 billion year, Earth would become uninhabitable. No, people don't talk about it, and it's a scary end. But I will tell you why it will happen. So I told you in the previous video that a star's core is the main engine of its production of light and heat and radiation. So what happens is that as it ages, its core becomes more hotter and more denser because more fusion is going on. So more hydrogen is getting converted into helium. So our sun is halfway through our its own life, and it is estimated that every billion years 10% of the intensity with which it radiates, it increases due to the core getting more hotter. So that's why after a billion years, due to the increasing radiation intensity, the earth's oceans will start to evaporate, and they will just crowd the atmosphere. And vapor is a good global warming agent, and it will plummet the global temperatures to hundreds of degrees, which will further cause more evaporation, and maybe some oceans would just evaporate away. Maybe the Pacific Ocean entirely evaporates away, and the sun's heat, it will never stop coming. The atmospheric water vapor that has evaporated, it will break down into its components, hydrogen and oxygen, and the hydrogen will just lift off into the space, and life will become uninhabitable on our beautiful planet. A very sad reality that we would have to face. But we should start thinking about solutions because humans have the mind. The universe has given us the capability to take charge to some extent. Maybe it has not, maybe it's our ego speaking, but still we should start going into the interstellar space. We should be stellar uh, travelers, and it should be our goal in the upcoming few thousand years. It's just long time span, but it should be our goal. And using our technology, space technology, and whatever we have, and maybe in a few years, maybe or a few hundred years, we would have much better technology, maybe a new kind of science, and we should use it to travel outside our solar system, outside our uh, towards certain other stars, and really be the travelers that we see in the pictures and movies. So, will you go on that journey? Do comment and do show interest. So, why and when did it all start? The primal human question that comes into our mind whenever we have this thing pinching us in our head. Oh, you have to know something. So, it was the light. So many religions have light comes to humans, information comes to him. Light is information. So the light that came from the stars, from our own sun, from all the luminous objects in the night sky, it was responsible for a scientific revolution. And what was that thing that caused the revolution? It was spectroscopy, a field of science that tells how light interacts with matter. Light interacts with matter, does it? Yes, it does. That's why we are living. We are alive because we are constantly interacting with the light of the universe. So, what's this spectroscopy thing? You might ask, and you might be interested in it. So, it's a kind of technique where you study the components of light. So, light is basically an electromagnetic wave, and a wave has an inherent wavelength and an inherent frequency, and these two things are related to each other. So what's the wavelength? So as you can see in the image, the wavelength is the distance between two high points, two crests, or maybe two low points, the two throws. For example, in an ocean, if you see a wave, the distance between two consecutive high points is its wavelength. and its frequency is how many waves are passing through, like how fast is the wave waving. For example, if you take a spring and you have one end of the spring in your hand and the other end attached to the wall, and if you shake the spring, it will create this motion, wavy motion. And the more energy you put, the more waves there would be, therefore more frequency. Frequency is how many waves are going into something in a certain period of time, but it's calculated per second. So yeah, so light is an electromagnetic wave, and each electromagnetic wave has a certain wavelength, and the wavelength is a description of that electromagnetic wave. So these luminous objects, all these are emanating light, these electromagnetic waves into the space which reaches us, and we use certain instruments like a diffraction grating in a prism to separate that electromagnetic wave, that light, into its specific components, and we see a pattern on the screen. And that pattern, after analyzing it, we can know what that particular luminous object is composed of. How do we know? So here we go into quantum mechanics. So quantum mechanics says it limits things. It is a limiting subject. So an electron, you know it has certain foundations on itself. For example, it can only go into certain orbital states. For example, it can move in only integral multiples of certain factors of radius, you know and not less, not more. Now, when it goes from one specific allowed orbital to another specific allowed orbital, it either loses energy if it goes from a higher energy orbital to a lower energy orbital, or it can gain energy and move from a lower one to a higher one. And it does so using specific wavelengths with specific energy. So, energy and wavelength are related by the formula E is equal to hc upon lambda, where lambda is the wavelength. Now, it's this E is equal to the difference between the allowed orbitals of the electron, and it can either emit it or it can gain it. So we have this continuous spectrum of light, of electromagnetic wave, and we have these two other spectrums, absorption and emission spectrum. So what's the difference? They are just the mirror image of each other, by the way. An absorption spectrum happens when a very hot substance emits photons. For example, the sun emits photons, and there is this cool gas around it, or a cool atmosphere around it, which has electrons orbiting atoms of the molecules that cool gas is composed of. So when these photons hit these electrons gain energy by absorbing the energy of the photon, and it's quantized energy. It cannot it cannot absorb a lot of energy. It can only absorb a certain packets of energy. So what happens, first you had this light coming, which was continuous. It was a continuous spectrum, and these electrons absorbed certain wavelength, certain energies, and this continuous spectrum has deficiencies now. These deficiencies appear as lines, these black lines on the continuous spectrum, and these black lines actually tell which atoms are those. So These black lines you can also see in the image, like the hydrogen absorption spectrum. You have these black lines, these certain wavelengths. So same is the case with the emission spectrum. It's like a very hot gas. It's been heated up a lot. So what happens is that when it heats up a lot, the electrons in that gas, they gain energy obviously, and they move to higher orbital. But a higher energy state is not sustainable for a long time. Everything that goes up will always come down in life also. We see things like nobody can stay there up forever. So electrons, they will lose energy eventually, but they will lose energy which is equal to the gap they traversed, and it is also quantized. So they will only lose energy which has specific wavelength, therefore specific colors. And we will see these colors as these blank, these lines. They are not black, they're just these colorful lines, as you can see in the picture. And all these colorful lines will have associated wavelengths, and this set of lines will define which elements atoms were those. It could be titanium, it could be iron, it could be mercury, it could be sodium, it could be hydrogen, it could be helium, it could be anything. So every element has a signature, and the signature is the spectrum that we get from it after we heat it up, or after it absorbs heat from another uh, heated object, luminous object. So this is how we know about luminous objects composition, a star's composition, what it's made up of, the elements that it's made up of. And it all led to the discovery of helium. And how was it discovered? It was discovered in the solar chromosphere. Chromosphere is the outside of the sun. During 1868 eclipse in where? India, in Guntur, Andhra Pradesh. And it was identified by a bright yellow line. As you see in the emission spectrum, these lines, there was this bright yellow light that they got in the sun spectrum. These two scientists, Pierre Janssen and Norman Lockyer, one from France and one from England. And this particular yellow line, it didn't match any known element at that time. So they said that it's a new element, and they named it helium after Helios, which is the sun in Greek, because it's something they got out of the sun spectrum. They used a classical optical emission spectroscopy technique to find the helium, and they observed this bright yellow emission line at this particular wavelength with 587.6 nanometers. Now it's called the helium line. So we get to know about spectroscopy and how it establishes that each element produces a unique set of spectral lines. And these spectral lines are signatures of the composition of the particular object from which we are getting this light. So, how amazing is the universe! It has deep secrets hidden, and we try to find them out through our physics that we made ourselves through observation and through hard work. So, I sum this up here, and the next video would be about the limb darkening of the sun and the virial theorem, and about a few other mathematical concepts, like how a sun collapses and what how much time it takes if the pressure that sustains it goes away, and a few more other things like the Thomson scattering also. I will try to explain it in a mathematical way. So if you like the video, you can comment, you can like it, you can subscribe to my channel, and stay with me. Thank you guys. Have a nice day.